Hello everyone, welcome back to Noob Engineering. Today we will start a lecture number 2 that is on types of condenser. It is also a chapter 1 second part. So let's begin without wasting time. So what is a condenser? A condenser is a device in various applications including air, conditioning, refrigeration and industrial process to remove heat from a substance, typically a gas or vapor, and convert it into a liquid. Okay, this is a simple definition of a condenser. So let me explain how a condenser works. You you have been seen a fridge. In backside of that, you will see this type of a condenser. So how does it works? Okay, see, here is the intake of an refrigerant that is in vapor form. Okay, see, this is the intake of a condenser that is in vapor form. Okay, vapor form. And as it goes here, it this is the path of the refrigerant throughout. Okay, now the main working of the condenser is to convert this vapor refrigerant into liquid form by extracting its heat. Okay, by extracting its heat. Now how does it does? Okay, these are the fins you will see here. This is the fin. Okay, these are the fins. This has a bigger surface area, so the refrigerant coming from the tube, this tube, it comes here, and as it passes, the heat is transferred to the surrounding, that is to this fins, and from this fins to the surroundings. Okay, and as a result, as the heat is extracted from the refrigerant, the vapor is converted into liquid. Is that so simple of a working of a condenser? So a condenser converts a vapor refrigerant to a liquid by condensation. This is called condensation. Okay, there are many types of condenser we have to learn in this chapter. So let's begin the types of condensers. See, in our syllabus, we have three types of condensers that are air-cooled condenser, water-cooled condensers, and evaporative type condensers. In air-cooled type condenser, they are natural air-cooled and forced air-cooled. Okay, and in water-cooled condenser, there are shell and tube condenser, shell and coil condenser, and double pipe condensers. Okay, now first of all, we will learn air-cooled condenser and its types. So, what is an air-cooled condenser? Just now I have gave you the example of the condenser that is also an air-cooled condenser. Okay, a type of an air-cooled condenser. An air-cooled condenser is a type of heat exchanger used in refrigeration and air conditioning systems to release heat from a refrigerant. It operates by using ambient air to cool and condense the hot, high pressure refrigerant vapor into a liquid state. It has two types that are follow: natural cooled condenser and forced cooled condensers. Okay, now you have come across this word ambient air. What is this ambient air? We have seen it from the first chapter. This is nothing but the surrounding air. Okay, so by the help of the surrounding air, The condenser converts the vapor refrigerant, okay, the vapor refrigerant into liquid refrigerant, and this process is known as condensation. Okay, now first we will see what is a natural cooled condenser. So let's move to our next slide. So this is the first one, that is a natural cooled condenser. So I have given you an example in the starting only, that was a natural cooled condenser. So a natural cooled condenser sometimes refers to a passive air cooled condenser, is a type of heat exchanger also used in refrigeration and air conditioning systems to release heat from a refrigerant. Unlike air cooled condensers, which uses fans to actively blow air over the condenser coils, natural cooled condenser rely on natural air flow for cooling. So see this last line, what does it says? Unlike air-cooled condensers, which uses fans to actively blow air over the condenser coils, natural cooled condensers rely on natural airflow for cooling. Okay, now I have given you an example of a fridge. Okay, that is based on natural cooled condensers. But how? The similar function goes here. See, the refrigerant that is compressed and converted into the vapor form. This is a vapor form of air refrigerant, passes in this tube. Okay, this is a tube, and by passing in this tube, at last it converts to liquid. But how? As I explained in the last slide, that is these fins. They are not drawn. I have taken this diagram from direct from the book. So okay, these are the fins. Okay, yeah, it's like this somehow. Now you have see this natural cool condenser rely on natural airflow for cooling. So there is no force, nothing other fan or any other thing to blow air through this fins. Okay, it naturally extract heat from the refrigerant by the surrounding air. Okay, by the surrounding air and converts the vapor into vapor refrigerant to liquid refrigerant. This is the simple natural air cooled condenser. Okay, now let's see the working. As I have explained you. See here, here's how it works. Coil design. Natural cooled condensers are typically designed with larger surface areas for condenser coils to enhance heat dissipation. Okay, where are they placed? Okay, this is also main. These condensers are often installed in locations where they can take advantages of natural airflow, such as on rooftops, in open spaces, or near vents or opening that allows air to pass through. Okay, airflow. The airflow is in natural convection, that is no forced the surrounding air. Okay, and the efficiencies, we talk about the efficiency. The efficiency is very less, generally less, and because there is no any forced convection there. Okay, and the simplicity is it is a very simple and cost effective, and it is easy to install and maintain because they do not require any electricity to power the fans. Okay, so they are basically easy to install and maintain, and plus they are cost effective. Okay, this was about all about natural air cooled condensers. Now let's move on this next part of the air cooled condensers, that is forced air cooled condensers. So what is a forced air cooled condenser? A forced air cooled condenser is a type of heat exchanger used in refrigeration and air conditioning to release heat from a refrigerant. Unlike natural cooled condenser, which rely on natural airflow, forced cool condenser uses fans or blowers to actively circulate air over the condenser coils, enhancing the cooling process. Okay, this is nothing but similar diagram of an natural air cooled condenser, but the main difference is it is the vapor is converted to liquid form by the help of a motor, a fan, or a blower. Okay, means it's just like giving an extra power to cooling the to converting the vapor into liquid. Okay, see the diagram here only it is says. Okay, see the liquid refrigerant, the vapor refrigerants enter here. Okay, it enters here, and this is an outlet of that. It get converts. This is in vapor form. Here it is vapor, and here it becomes liquid. Okay, this is the main thing that changes the game. Okay, by this the efficiency of the condenser increases, that is efficiency increases, and by the increase in efficiency the work to convert the vapor into liquid, the time required to convert the vapor into liquid becomes less. Okay, so this is only the working of a forced air cooled condenser, nothing much. Let's move on to the working of it. Okay, a fan or a blower. Yeah, you saw it. You saw it. A forced air cooled condenser is equipped with one or more fans or blowers that are electric powered. These fans are strategically placed to the direct airflow where the condenser coils, and something is of coil design, that is are designed to maximize heat exchange with the surrounding air. Refrigerant vapor enters the condenser coils at high pressure and temperature. Okay, you can read it. I will give you some 30 seconds. You can read all this. Something is like airflow. The fans or blowers create continuous flow or of air over the condenser coils. All is just simple. No need to take any load. Okay. And the as last is efficiency. Forced cooled air condenser are typically more efficient than natural cooled condenser. Yes, because they can maintain consistent cooling performance regardless of environmental conditions. Yes, they are effectively in both hot and cool climates. Yes, they are effectively in hot and cold climates. So let's move on to the third condenser of water cooled condenser, that is, first we will see what is a water cooled condenser and then we will move on to the types. A water cooled condenser is type of heat exchanger used in refrigeration and air conditioning systems to release heat from a refrigerant. Instead of using air like cooled condenser, water cooled condenser use water as the cooling medium to remove heat from the refrigerant. Okay, now what we saw in air cooled condensers, the the medium that is there in air cooled condensers was air, and Here we can see it is water. Okay, there are three types of condensers here in water cooled condensers. Okay, it is shell and tube condenser, shell and coiled condenser, and double pipe condenser. These three are main in our syllabus. Okay, the questions may come on this. So listen carefully. So we will begin with the first one, that is shell and tube condenser. These are easy, man. No need to take any tensions. See, the first one is shell and tube condenser. So before reading the definition of a shell and tube condenser, see the diagram and just think of how it works. Okay, you can make your own points after clearing the concepts. Okay, see, I will mark it with this. Okay, this is, you are seeing in this blue line, I'm coloring it red. This is our main, that is a refrigerant. Okay, and wait, and this all are water tubes. Okay, these all are water tubes here. Okay, and at the entrance the refrigerant is again in the vapor form, and while the exit it comes in liquid form. Okay, but this time the medium to cool or to extract heat from the vapor refrigerant is done by the air. The medium is here is water. Okay, but why water? Water extract heat faster than air. Okay, that's why water is used here. Okay, these mainly these types of condensers are used in uh, big industries that are uh, used today. Okay, they use this only, straight tube heat exchanger. Okay, so let's move on to the definition as we discussed here. A shell and tube condenser is a type of heat exchanger used in various applications including refrigeration and air conditioning systems, industrial processes and power plants. It's designed to transfer heat and condense a vapor, typically a refrigerant or a fluid, into a liquid state by facilitating heat exchange between the vapor and cooling fluid, often water. Okay, so let's move on to the working. See the structure. A shell and tube condensers consist of a cylindrical shell, that is an outer casing, with a bundle of tubes inside it. The tubes are typically made of metal and they run lengthwise through the shell. Okay, and the hot vapor flow, that is a refrigerant flow, enters the shell and tube condenser and flows through the tubes. As it moves through the tubes, it loses heat due to its contact with the tube walls. Okay, where cooling fluid, that is nothing but water, comes in contact with the refrigerant and exchange the heat with the water, and hence the vapor refrigerant is condensed and it changes its phase from vapor to liquid. Okay, so it is this was its working. So we will move on to the next part, that is the next is shell and coil condenser. So a shell and coil condenser is a type of heat exchanger that is used to condense gases. It consists of cylindrical shell, that is this one. This is the shell. Okay, and that contains a coil of tubing. This is a tube. Okay, this one. The gas to be condensed flows through the shell while the cooling fluid flows to the coil. Now in the first slide, recent slides, we see that both the refrigerant and the fluid both are in the tubes, but this time the cooling water is in the coil and the vapor refrigerant is not in any tube or nothing. It is in the shell. Okay, so as the refrigerant moves in, that is a vapor refrigerant, the cooling water simultaneously comes in. Okay, as it comes in contact with the coil, it starts to exchange heat. Okay, it starts to exchange heat, and at last, you can see here, it is converted into a liquid form. The vapor, that is vapor refrigerant, is converted into a liquid refrigerant. Okay, and by this, the cooling water goes out. This was the simple working of a shell and coil condenser. So let's go on the working. Here's how it works. The gas to be condensed enter the shell of the condenser at the top. The cooling fluid enters the coil of the tubing at the bottom of the condenser. The heat from the gas is transferred to the cooling fluid, causing the gas to condensate. Okay. The condensed liquid collects all the at the bottom of the shell and is then removed. The cooling fluid can be water, air, or any other fluid. The type of cooling fluid used depends on their applications. For example, water is often used as a cooling fluid in refrigeration and air conditioning systems. Air is often used as the cooling fluid in industrial applications such as chemical processing and power generations. Okay. Shell and coil condensers are important part of many different systems. They are reliable and efficient way to condense gases. I have no need to write this. I will provide you the notes and the important questions in the on my Telegram channel. You can go in the description. The link is there. Just click on it and join my Telegram channel. All the updates, all the questions, all the notes will be shared there. Okay. Let's move on to the next part. It is double pipe condensers. Now what is this? The double pipe condensers. A double pipe condenser, also known as double pipe heat exchanger or tube-in-tube condenser, is a type of heat exchanger used in various applications include refrigeration and air conditioning systems, chemically process, and industrial processes. It is designed to transfer heat from hot fluid, usually a vapor or gas, to colder fluid, typically a liquid, by facilitating heat exchanging between the two fluids. Okay, now you can see the diagram. So the surrounding fluid, that is our water, is in now the shell. Okay, and the refrigerant is in the tube. Okay, this is our refrigerant. Okay, now this time the refrigerant is in tube and the water is in shell. The same processes, the same working, and the same output. So no need of explaining, I think so. You can get it. So we will go to the working only. See, a structure. The structure of it. A double pipe condenser consists of two concentric pipes or tubes, one inside the another. The inner tube carries the hot vapor gases, such as refrigerant vapor, while the space between the inner and outer tubes is used for the flow of colder fluids. Okay, just as now we discussed that the outer surfaces carries water and the inner surfaces, that is the tube, carries refrigerants. Okay, The working is same. It is convert the vapor is converted into liquid. Okay, so let's move on to the next one. That is how. So let me tell you, this question has come many time in the exams. That is comparison between air cooled condensers and water cooled condenser, or differentiate between air cooled condenser and water cooled condenser. Okay, so this is one thing, important thing. I think so. It is a very IMP. Okay, so let's start. Cooling medium in air condenser. What should be the medium? The medium should be air, and here the water cooled condenser. The medium should be water. Okay, heat dissipations. So how it is done? Natural or forced convection. Okay, as we discussed now before, and here by circulating only water. So efficiency. When we talk about the efficiencies of both the air cooled condenser and water cooled condenser, the air cooled condenser is typically lower, okay, than water cooled condensers, but but they both are equal, not equally lower. Okay, this is not equally lower. Performance in hot environments. Reduce efficiencies in high ambient temperatures. Okay, if the vapor refrigerant coming from a condenser compressor is or is already in high temperature and high pressure, okay, has an high pressure and temperature, so when the surrounding air is also in a high temperature, so the condensation is not proper here. Okay, in air cooled condensers, the ambient air or the surrounding air that we are providing to the condenser should have less temperatures than the vapor refrigerant. Okay, that's why it is only suitable in a cool temperatures. Okay, and this maintains efficiencies in various ambient conditions. It doesn't affects any environmental conditions, and any environmental conditions cannot affect this. Okay, and the we have to talk about the space requirement. Larger footprint and smaller footprint means is require smaller or larger spaces. Maintenance generally easier and may require more maintenance due to water treatments. Yes, initial cost it is lower and this is higher as discussed. Applications commonly used in residential and smaller commercial systems, and here in larger commercials and industrial systems. Okay, so this was the differentiate. You can say you can take it as a differentiation, or you can take it as comparison. You are smart, you can convert it to anything. Yes, but this is an IMP. Don't let it go. It can come in exam. So let's move on the next part, that is last condenser of our chapter, that is evaporative type condensers. So what is an evaporative type condenser? This is the if means what we can say most efficient type of a condenser used in today industries. Okay, so what how does it works? Let's see. An evaporative condenser is a type of heat exchanger used in an air conditioning and refrigeration systems to release heat from the refrigerant by evaporating water. It combines the functions of a condenser and a cooling tower, making it efficient in dissipating heat and maintaining cooling performance even in high temperature conditions. Okay, see this last line, even in high temperature conditions. Now you understand why I say it is more efficient and more used. This is the main reason of it. Okay, now let's come to the diagram. So what can you see here? The components. This is a water pool, or you can say a reservoir. Okay, reservoir. It wire. Okay, and this is a pump. This one is a pump. Okay. Okay, and here is the water supply. These are the sprayers. Here you can say these are the sprayers, these are the fans, and this is the refrigerant inlet, and this is the refrigerant outlet, and this is the air inlet. Okay, and this is the air outlet. The working is very simple. Just listen and understand. So this is the coil where the refrigerants are carried out. Okay, so it moves from here and comes here. Okay, the inlet is again the vapor in vapor form, and the outlet is in liquid form. Okay, now we will start to see the working. As the refrigerant, so from here, as the refrigerant enters, the water is pumped and sprayed out by the nozzles or by the sprayer in the container. Okay, and simultaneously the airflow also is there. Okay, by both the air and water medium, we can get the very hot refrigerant moving in the tube, cooled within some time. Okay, and the air which is passing by from this is extracted by the fans located up here. Okay, as the refrigerant moves from this, and the water and air, it comes in contacted with it, and by the both, the heat exchange is in a very big form. Okay, so the efficiency increases in it. Okay, understood the working. Now let's see. So now here is the working of an evaporative condenser. First one, that is refrigerant flow. So the refrigerant flows from a high pressure refrigerant vapor enters the evaporative condenser. Okay. Water flow. The water is pumped to the top of the condenser and distributed over the condenser coils or tubes. As we discussed, it sprays out the water from the nozzles onto the tubes. Okay. And the heat exchange takes place and converts the vapor into liquid form. Okay. Now you can read here the remaining part, that is heat exchange, where evaporation, cooled liquid refrigerant and cooled water. Okay. As you are reading this, I would tell you that we have finished here the condensers part. Okay, types of condensers part, and next will be the types of evaporators used in HVAC. Okay. After that, the expansion walls or types of expansion walls. Okay, so we will stop here. We have finished our second lecture here. uh, I request you all to subscribe, like, and share the video to your friends who are in need, for the who doesn't understand the subject, that is HVAC, the most hard and the difficult subject in B, and that is mechanical engineering. In mechanical engineering. Okay, so see you in the next video. Keep learning. Bye.